This is a review of question 2 in exam 4. A 100-gram ball of clay traveling at speed 10 meters per second sticks to a 1.0 kilogram brick, which is sitting at rest on a frictionless surface. Part A of this question, what is the speed of the brick after the collision? So let's draw this example. We have the ball of clay. Its mass is given as 0.1 kilograms. And its velocity is 10 meters per second. And it collides with a stationary brick, mass 2. Which has a mass of 1.0 kilogram. After the collision, mass 1 sticks to mass 2. So we have an object whose mass is equal to mass 1 plus mass 2, moving off with some final velocity, capital B, big V. And we're asked to find what the value of big V is. So we apply conservation of linear momentum, since there are no external forces acting on the system. The linear momentum is conserved, which means that mass 1 times V, which is the initial momentum of the system, is equal to the momentum after the collision, mass 1 plus mass 2, times big V. So the final velocity is equal to the ratio of mass 1 to mass 1 plus mass 2 times little v. So in the numerator we have 0.1 times 10 meters per second over the sum of the two masses, 1 plus 0.1, which is 1.1. We have kilograms in the numerator and kilograms in the denominator. They cancel out. So we put that in our calculator, and our result is 0.91 meters per second. Part B, what percentage of mechanical energy is lost in this collision? Well, there's no change in potential energy since the motion is horizontal. So the only change in mechanical energy in this collision is the change in kinetic energy. So we want to find out how much kinetic energy is lost. In other words, what's the difference between the initial kinetic energy and the final kinetic energy? And we divide that by what our initial kinetic energy was before the collision to find the percentage lost. So this is equal to 1/2 m1 v1 squared minus 1/2 m1 plus m2 v2 squared over 1/2 m1 v1 squared, which is equal to 1 minus, the halves cancel out, so it's the ratio of mass 1 plus mass 2 times v2 squared, which we would call in v, big V squared, over mass 1 times little v squared. This is 1 minus (1.1) kilograms times final velocity squared, which is 0.91, over the initial mass, which was 0.1 kilograms, times the initial velocity, 10 meters per second, squared. And this is equal to 1 minus 0.091, which is equal to 0.91. Sorry, I lost my pen. Here it is. Or 91%. So that's part B. And then part C is perfectly inelastic, which is the case whenever you have a collision between two objects, and then after the collision, the two objects are joined together. And that concludes this review of question 2 in exam 4.